All right, Bismillahirrahmanirrahim. We shall continue our lecture on the metal forming, but today we will be focusing on the bulk deformation processes, in which we will be focusing on the forging process. So in general, forging process involves the plastic deformation of materials between two dies to achieve desired configuration. If you see in the figure, the dies will have the upper and lower part. In between, there will be the work in piece, in which will be the materials to be processed to the desired shape. In here as well, we can see that the force is exerting towards down, which is downward going with certain velocity. In forging, favorable grain orientation method is obtained, in which that the grain orientation is one of the consideration that we can do something about, in which every single material that has the structured changes will affect the properties of the materials once we change the whole structure of the materials. Let's talk about the open die forging. So open die forging is originally gets its name from the fact that the dies, which is the surface that are in contact with the workpiece, do not enclose the workpiece. It means that it is open. Okay. In this system, the metal is compressed by repeated blows by a mechanical hammer, and shape is manipulated manually. Okay. Therefore, the operator needs to orient and position the workpiece to get the desired shape. So, meaning that you decide what kind of shape you wanted it to be. Meanwhile, for close die forging, is that, or we call it as well impression die forging, is the shaping of metal completely within the walls of cavities of two dies that come together to enclose the workpiece on all sides. It means that the system is a closed system. The desired configuration is obtained by squeezing the workpiece between two shape and closed dies. So in here, if you can see on the figure on the top of our presentation slide, there is an upper and lower dies, and the workpiece positioned in between the two dies. We can see that the lower die will be the stationary, and if you see, once we are putting some forces from the top to down, uh, there will be a flash. Flash is like a residue. Once you have putting some stresses, and of course your materials or your workpiece will be having some extended part of it after we fitting in the die shapes. Some case study. This is something that we can discuss here. The quality of the forged parts. Okay. In here, forged parts are much stronger and tougher than cast parts made from the same materials. So in here, as a representative from metal industry, justify this statement to your client with respects to the microstructure of the metal. So to discuss about this query, we should understand that these two processes are different. Okay, they came from the same type of materials, which is constantly to be evaluated, but here between forge and casting, the principle will be different. Okay. If you see the figure, the hammering process arrange the microstructure of the metal so that the crystal grains get aligned along the part profile. This leads to an increase in its strength. It is therefore common to use forging to make parts that will carry very high stresses during the application rather than casting. So if you see on the figure on the slide, the original coarse grain structure, and after having the plastic deformation, which is the elongated grain, can be seen after it fits the die, and the recrystallization effects grain can be seen here after we get the elongated grains, and finally the growth of the new grains can be seen at the right part of the structure. Okay. So that's why the casting and the forged materials, cast and forged material have different properties. Everything is now depending on the structure that it can offer. Moving on, that we have the third one, which is the extrusion process. Okay, extrusion process is a metal forming process involving shaping a metal billet by forcing it through a die with an opening. The figure that you can see here is enough to explain what is the principle of extrusion. Okay, we are having the workpiece in the die, and we have the ram. We basically are pushing the ram so that the material fits into the die. At certain velocity, the materials will be pushed and the outcome will be after the die. And many types of extrusion are available. In here, there is a direct extrusion. It means that just put the force from the ram to the container, and you have the billet. Billet is the raw materials. Okay, and then you have the die, and all the billet pass through the die, and then we can get the extruded part. Okay, the metal billet in this case is placed within the container, and some explanation are available here. Okay, indirect extrusion is different. Okay, it means that we are having the force at different angle. It means that in here you can see that the die itself is moving on towards the billet, and the billet is only staying over there. We move to another process, which is drawing. Drawing is like the other way around, or another side of extrusion. Okay, if extrusion is pushing, drawing is like you are pulling. So by definition, drawing is a metal forming process involving pulling a workpiece. It means that you pull the workpiece through a die, providing reduction of the cross-section of the workpiece. Drawing is the process most commonly used to make wires from round bars. Okay, you can see on the figure, it's very helpful to explain to you. Just pull the billet through the die, and the workpiece on the left will change its thickness. Therefore, you'll get something after you pull the workpiece through the die. So this process is very similar to extrusion, except this is the thing that I've said just now, except that instead of pressure from the back end, in drawing, the wire pull from the side where it emerges from the circular die. A few definitions that is important when we deal or we are trying to understand the metal processing. Number one is workability. What is workability? Okay. By definition, workability, something work and ability. In here, we define it as to the relative ease, how easy it is. With each, a metal can be shaped through plastic deformation. It means that how easy for you to change the shape of your materials through plastic deformation. Plastic deformation in here carrying a weightage of permanent deformation. So the term workability is often used interchangeably interchangeably with the term formability, and preferred when referred to the shaping of sheet metal parts. Okay, when we talk about metal sheet parts, it is preferable to use formability. However, workability is usually used to refer to the shaping of materials by such bulk deformation processes as forging, extrusion, and rolling. So the evaluation of the workability involves both measurement of the resistance to deformation, which is the strength, and determination of the extent of possible plastic deformation before fracture, which is the likelihood. Okay, here I think we can see what are the differences in terms of the advantages of each process that it can offer, compared to the drawback or limitation that it would have. So you might want to have a look after into detail. All right. I think that's it from me today. Thank you very much. Assalamualaikum.